All right, this is 6.2, solving quadratic equations by completing the square. So we have talked a lot now about why we are doing this with quadratics, the different forms of quadratics. Okay, what are they? There's three forms. You can tell me very quickly. You have no kids? Standard, vertex, and factored. Now we've worked a lot with standard, and now we've done a lot with factored. Hopefully you guys did a lot with factored over the weekend. Now is the third one. We're going to work with vertex form. Okay, so we are solving quadratic equations by completing the square. This is all about vertex form. Okay, this is when you see completing the square, we're talking about vertex form. Now, why is vertex form so important? Why do we want to know how to convert to vertex form? Why? Yeah. Yeah, so we can find the vertex. Vertex arguably is the most important thing about the quadratic graph, right? When we find the zeros, one of the reasons we find the zeros is so we can also find the vertex. Okay? The zeros are important, the vertex is important. Okay, so there is a specific way to convert from standard form into vertex form, and that's called completing the square. Okay, so that's what we're learning about today. All right, so this first example, it says expand this to get an equivalent expression. So we need to expand this, so the way we would do that is we would write out the square, leave the negative 4 on the outside. Okay, we get x squared, I'm going to do FOIL here, and then 3x, and then 2x, right? So plus, sorry, the first one is 2x plus 3x plus 6 minus 4. So we get x squared.
So why is it x plus 2?
Because I messed up.
Okay, so you'll zoom in on it a bit more.
Yeah, a little bit. X squared plus 3x plus 3x plus 9. My bad. So 6x plus 9 minus 4 is 5. Okay, so this is our equivalent term to this. Okay? Now, if we remember vertex form, it looks like this. Okay? So now we have our standard form, which is this. We've just expanded it. This is standard form. And we have our vertex form. That's our vertex form. Okay? Now the nice thing about vertex form, we're going to see it in a minute, but the formula is in this format where positive h, not negative h, but positive h and k is the vertex, right? Our vertex is hk. So remember, in the formula it's negative h, but in the actual point it's positive h. And the k is the same. All right, so the vertex then for this equation would be what? What's the vertex here? Alan? Negative 4 is right, but 3 would have the opposite sign in the formula, so it would be right. Okay, that's what we're trying to do. We're trying to get vertex form. Now here I've gone the opposite way. I took vertex form and I converted it to standard form. We're going to figure out how to go from this back to this. But we're just showing that you can have expressions that are equivalent, that are in different formats, right? We're just changing them around. So we're going to expand this to get an equivalent expression. So we're going to leave 2 on the outside. X minus 4 plus 5. We're going to say 2 x squared minus 4x plus 16 plus 5. Now we get 2. We have this expression here. So we get x squared minus 8x plus 16 plus 5. So we multiply that out times this. We get 2x squared minus 16x plus 32 plus 5. Now this is equal to 2x squared minus 16x plus 37. Any questions there? Okay, so all I've done so far is take vertex form and I've converted into standard form. There's vertex form, there's standard form. What do you notice about vertex form and standard form? What variable do they share? There's one variable, there's one common thing that you learn about the vertex, or sorry, about the parabola that they share. Can you see it here? This value? Yeah, the A value is common, right? The A value is 2 here in vertex form, and it's also 2 in standard form. What would it be in factored form? Come on, guys. KG, what would the A value be in factored form? It's at the beginning. 2, yeah, it's always the same. A is the same for all 3 forms. Okay? You should know that. So the A value doesn't change. In this case, it's 2. All right, so the other way around now. Can we rewrite the expression, this in standard form, as that in vertex form because they're equivalent? Similarly, we can rewrite this as that because they are equivalent. And you know that by expanding this out, you would get this, right? So that's what we're trying to do today, okay? So, the definition, a process of expressing standard form, y equals ax squared plus bx plus c, in the form y equals a x minus h squared plus k, which is vertex form, is called completing the square. Okay, I'm going to say it one more time. Completing the square is transferring standard form into vertex form. You guys understand? Anyone asks you, what are you doing completing the square? What's the point? I'm moving standard form into vertex form so I can see the vertex on the graph without graphing it. All done algebraically. Do you understand? You guys understand why we're doing this now? Why not just graph it out and then see where the vertex is? Why not? What do you think? Yeah, exactly. It's way faster to do this. Graphing it out, how would you even start? You'd have to do a table of values to graph it, right? Assuming we don't have a graphing calculator, it would be a nightmare. I mean, you could do it, but it would take you about 10 times as long. All right, so completing the square when leading coefficient is equal to 1. So when this A value, so A is equal to 1, when it's A value, all of your terms are going to look like this. Okay? All right, so we need to complete this square. So first off, we're going to deal with perfect squares. Now, we've done this before. Can anybody convert this into a perfect square term? Did anybody remember this? This is 2 sections ago, or 1 section ago. Yeah, Javed.
X minus 3.
Yeah. You guys remember how we did this? It's the square root of the first term comes down. The square root of the last term comes down. This sign is the middle sign, and the middle term has to be what? In order for us to be able to do this. Sorry? No, not quite. Yeah, Adrian. It's 2 times the product of the first and last term square rooted. All right, so in other words, the square root of this is x, the square root of this is 3. 3 times x doubled is 6. Right? Do you guys remember that?
Yeah.
You have to know that, or we can't go on. We cannot go on if you don't remember that. We'll say it again. You know, because all we're doing here when we're completing the square, Jaden, is we're creating perfect squares. That's what we're doing. So if you don't remember what a perfect square is, you can't go on with this lesson. You've got to remember that the middle term is twice the square root of the two end terms multiplied by each other. Okay, twice the product of the end term. Okay, so here again, we're going to see, is this a perfect square? Is 8x twice the square root of this and the square root of this. So let's see, this is x and this is 4. 4x is 8 twice? 4x? Yeah. So we know this is a perfect square. So then what I do, I take the square root of this, I take the square root of this, right? Square root of that, square root of that. And then what's this middle term here in the middle, Max? Is it plus or minus? Plus. Why is it plus? Because of that. And then I have to make sure I put a square on the top, obviously. Okay, last one, who wants to try this? And fill it all out. Yep.
X minus 1.
X minus 1. Very good, right? Square root of x, square root of 1. 1x is 2 double 1x. Yes, it is. It's a perfect square trinomial. Boom. All right. That was a little quick review. A 3-example review. Now, we're moving on. We're trying to figure this out now. What term completes the square? All right, so we're looking for the missing term that makes this a perfect square. All right, engineer, can you figure this out? What would the term be here that would make this a perfect square? Not 10. No, not 10. Okay, remember, this middle term, engineer, has to be twice the square root of this and the square root of this. So what number does this have to be in order for when you take the square root of it, times x times 2 is this? It's kind of a lot of backwards working. Got it? No, not 100, Tony. 25, very good. Yeah, okay, I'm going to explain it. So the square root of this, x squared, is what, engineer? X squared is what?
How many x? Sorry.
X, the square root of 25 is what? 5. 2 times 5x? 10x, right? So this is like this. Make sense? Okay, you want to try this one? You can do it, right? Square root of this is x. Square root of what gives us doubled 14x? What would you have to put here? Might be easier to start down here. What needs to be doubled to give you 14? 7, good. What sign is here? No, what sign?
Positive.
Yeah, positive, because that's positive. This is a square. Okay, so then what is up here? Something you have to take the square root of to get 7. You got to know 7 squared. Yeah, you can use your calculator. 49, yeah. You did all the work for him, engineer? So no problem. You knew what you were doing. You just had to grab your calculator for that. That's not a problem. If you don't remember 7 squared, that's fine. That's why we have calculators. All right, Stefan, what's the square root of x?
X.
Sorry, yeah, square root of x squared, x, good. What sign am I going to put here?
Minus.
Minus, okay, squared. What number now do I have to take the square root of to give me half of 20? Or sorry, let's just start with what's half of 20? 10, right. So this is 10. Okay, now what is 10 squared? It's going to come up here.
100.
Yep, you got it.
Sir, I can do the last one.
Yeah, okay, go ahead. X.
Alright, so X and then negative
Yep,
and then 11
yep. Half of 22 is 11. Yep, squared.
and 121.
Very good. Yep, you got it. You got it. We're almost there. We're almost there. This is now finally the lesson. This is the lesson. We've done all the backup work. We've got you there. Now this is the lesson. This is how you complete the square. We are going to artificially create perfect squares. That's what we're doing. We are deciding on the number to make a perfect square. So let's watch how we do this. So we're going to say okay, so we have x squared plus 12x. Now what we want to do here, I'm going to put this in brackets, and I'm going to leave my 25 on the end. Okay? Okay. Everyone's okay with so far what I've done? Do you see how I haven't changed anything with the equation? Is everyone okay with that? Just added some features, I added some brackets. And what I'm doing, the reason I added those brackets is because I want to create a perfect square. Yeah.
So we're to the x squared take away x plus like which is how do we get, I know we get the one thing on like squaring it, like the square root.
Where are you? Over here?
Yeah.
Over here?
Like all the numbers like 100, 121, 49, you get the
Yeah.
square root.
Yeah.
But like, I usually have to go to the trial and error. Is there a way to find it? Like, because it's.
Yeah, it's 7 squared. It's 49. And 7 is half of 14. That's how you find it.
But if I put 7 into a calculator and put 7 squared, it gives me like.
49.
No, it doesn't give me 49.
7 squared?
Oh, squared. I thought you meant square root.
No, squared. It goes this way, right? Max's, it goes this way is squared, this way is square root.
Oh.
Okay. Everyone is okay from here to here. Say yes. Forever hold your peace. Yes? Okay. What number do I need to make this trinomial a perfect square? Rudy, we're doing the same thing that Chenier did over here. We're just doing it inside the bracket. What number do you need there? I'm just going to move this over so we have space. Rudy, what number do I need here to make this a perfect square trinomial? It's half of 12 squared. Right? Half of the middle term squared. Yeah, same thing we did up here. You were trying to find this third number here for these two numbers. So the middle term is 2 times the product of these two terms times 2. So this term divided by 2 squared. That's what we're looking for. So we're looking for this number here has to be 12 divided by 2 squared. Yes, 36. And is it positive or negative? Right, positive 36. Now, that's what we want, okay? Here's the problem with that. Here's the problem if I left that. I can't just add 36 to the right side of an equation. I can't just do that. No, wait, I can't do that. Because now I would have to add 36 to my y, right? I'd have to say plus 36 on this side. Because whatever we do on the right side, we have to do on the left side. But what I can do, I can add 0, right? So if I add 36 and minus 36 at the same time, I'm actually not adding anything. You guys are like, what the hell are you doing, Mr. Mills? What the heck are we doing now? We're just adding 0. That's what we're doing. We're adding 0 because we're adding 36 and minusing 36. So we're creating this this artificial scenario where we can pull out a perfect square. So see this 36? I need to get it out of the brackets because it's in brackets here. There's a 1 in front of the brackets. 1 times negative 36. We'll jump that 36 out. So I can rewrite this as x squared plus 12x plus 36 minus 36 minus 25. Any questions there? So it didn't look like I had to do anything here to get the 36 out. But as soon as your a value is not 1, you're going to need to multiply that 36 by whatever the a value is. So that's why I'm showing this step. 1 times negative 36 that comes out of the brackets. Is there any questions up to there? Okay. Now there's 2 things I can do to finish this off. This I'm going to convert into my x, my bracket term squared, because it's a perfect square. How do I know it's a perfect square? Because we made it. We made it a perfect square on purpose. We chose this number, 36, so I know it's going to be square root of this, squared. I know I can convert that trinomial into this binomial square because I chose that number specifically in order to do that. Okay, and now the last step, I need to combine these 2 terms. 36 and 25, I think, is 61. So what have I done here? I have rearranged my standard form into my vertex form. That's what we've done. And what is the vertex here, Rudy, for the record? The vertex? The vertex is an x and y coordinate, right?
Oh, so 1 and 6.
No. If you can't pick out the vertex here in vertex form, we're going to have a whole bunch of trouble. That's the reason we're doing this. Vertex form is over here, Rudy. What's the vertex here in this?
H and K.
Sorry?
H and K.
Yeah, H and K, exactly. So what's the vertex here?
So 6 and negative 61.
Sorry?
6 and negative 61.
No. I got a problem with the 6. Not positive 6? Yeah, you have to change the sign, right? Because this is negative H. And the vertex is positive HK. So whatever the sign is with the X, you have to change it. Now, if you did all of this great work and you can't pull the vertex out, or you pull the one sign wrong, you say it's negative when it's positive when it's negative, all of the work you did is for nothing. Because now when you go to answer the word problem, your answer is not going to make sense. You have to know that. You have to remember that the vertex is HK. This changes sign and this sign stays the same. Completing the square. Next one. X squared minus 10x plus 11. Who wants to try? Yeah, go ahead.
Y equals x squared minus 10x minus 25 minus 11.
Okay. Why? Explain the minus 25 and explain the minus 11.
Sorry, plus 11.
Okay. Better.
You have to add brackets around 25 and x.
Like this?
Yeah.
Okay. But you haven't done something.
I have to add a plus 25.
Yeah, you have to add a plus 25. Now, the plus 25 is the third term. This third term has to be positive. So that the plus 25 is what you want to come first, right? You want to do plus 25 minus 25 plus 11. Does that make sense? This term for your perfect square trinomial has to be positive. So you're always going to add and then subtract. Always. Because you can't take the square root of a negative number, right? If you put the negative 25 first, you're going to have to square root that to get the perfect square, and you can't. Yeah.
So when you like moving like a number to the other outside bracket,
Yes.
does it matter if it's positive or negative?
Yes. It's negative. It's always going to be negative. You're always getting rid of the negative one, depending on what the a value was. If the a value was negative 1, then it would be positive. If the a value was 2, it would be 2 times this value, negative 50. Okay? But here we're dealing with a values of 1, so we actually just can jump it out, right? It's 1 times negative 25. So you're left with this. Do you guys understand that? Max, you understand this? Any questions? So ask me, what are you confused about?
Like, why do you need to like make it a 0 so you can like put it in the same?
Why do I need to make it a perfect square?
Yeah.
So I can put it into this form, so I can just pull out the vertex. That's the whole reason. The whole reason we're doing this is so that it ends up looking like this, ax minus h squared plus k, so that we can just look at it and pull out the vertex. That's the whole reason. I know it feels sort of pointless, adding a number, taking a number away, it seems kind of dumb, but the whole reason is just to rearrange it so we can see the vertex. Okay? All right, so the next step is then, what's the square root of x, Max? X squared, sorry, is x, yes. And what sign am I going to put here? Yep. And then what's the square root of 25? Okay, all of this what? What do I got to put? Yeah, squared. And then minus 25 and plus 11 is what? Minus 14, I think. No. Yeah. Yeah, minus 14, right?
Yeah.
Okay, so Max, what's the vertex?
Minus 5, minus 20.
It's minus 14. You did the same mistake as Rudy. It's not minus 5.
It's 25.
Nope.
Squared.
Nope.
It's x then.
Remember the sign here is minus h. If your sign here is minus h, so here your vertex would be?
Plus 5.
Yeah. Plus 5. That's your vertex. That's your vertex. Depending on what it's asking for, that's your vertex form. That's your vertex. All right, this one here. Okay, let's go a little bit quicker. So we have x squared minus 3x. Now we need to find a number that is half the middle term squared, right? So 3 divided by 2 squared. That is going to be 9 over 4. Does everyone understand that? When you have a fraction that's squared, you square the top and square the bottom. You got to know that. So we're going to add 9 over 4, and we're going to subtract 9 over 4. And all of that stays in a bracket, minus 4. Okay? Now we take the square root of this, square root of this. Okay, so we end up with x. And the square root of 9 over 4, which is a perfect square, we know because we created it, is going to be minus 3 over 2 squared. And then we have that minus 9 over 4 jumping to the outside. That needs to be combined with the negative 4. So we're going to get x minus 3 over 2 squared. We're going to have minus 9 over 4. When we deal with fractions, we have to deal with a common denominator. So the 4 is going to be over 4. So we have to multiply both by 4. So we get 16 over 4. Right?